Hello everybody, so today I will talk about the chemistry. The topic today is about equilibrium constant. So I will use one example to illustrate how to do this using the standard deduction potential, and we have the table in here. This is the table of the standard deduction reduction potential of the 25 degrees Celsius, or we have 298 K. This is the standard number for you. First, we need to use the half cell reaction in here. So we need to find about the copper and about the Ag in here. So in the copper, they agree about 2 plus. This means they will share about 2 electrons for you. That's why this CO is got about 2 plus. However, in Ag, that's about silver. You got about 1 plus in here. However, we have number 2 and number 2. That's why we have 2 Ag and 2 Ag in here, and we need to receive 2 electrons. So we will find about the voltage in here. So we will use this table and we put down EO in here, and we got about 0.34 and 0.8. We sum two numbers together, we got about EO. And the next one we have the capital K EQ. That's about equilibrium constant, and that's the formula is about 10 power NEO divided to 0.059. So in this one we have EO, that's about 1.14. we put in here, and N is represent is about the number of electrons. That's about 2E. we put in the N. So we calculate this number and we got about equilibrium constant in here. Similar this one, we got about B in here. After that, we need to find which one reducing, which one is oxidating. So we got about CE and PI. So in the CE we got about 4 plus, but after reacting we got about 3 plus. If we see on the chemical reaction, we got about 3 CE and 3 CE in here, we put in here. And because 4 reduced to 3, only 1, but we have 3, that's why we send to 3 electron in here. The next one about bismuth, we got about BiO and we have plus. We know oxygen is about -2, so that Pi in here they got about 3 plus, that's why we put in here. And bismuth will receive about 3 electrons, so that the donor and receiver, they should have the same electron in here. That's about number 3. Later that we put about find about the table. We use the table in here, and later that we input the number and we use the formula in here. N is represent number 3, and we got about number 3 in here, and we calculate the EO, but I cannot find the bismuth in the table. So that you sum two number together and you put number in here, and you got about the answer in here. Similar this one, you got about N2H5 plus. This is about -2 because hydrogen is about +1. We have 5 is about 5 plus, but in this one is about -2 because -4 plus 5 plus, you got about the plus in here. That's why the oxidation state of the nitrogen is about 2 minus. In this one is about the gas, it should be about 0, and we have 2 and 2, that's why we put number 2 in here, and we got about 4 electrons. Next one, about the iron, we have 3 plus and 2 plus, but we have number 4 in here, so that we got about 4 electrons. So that you use the table in here, and you will put about the standard reduction in this one, and you apply the formula. N is about 4, and you find EO, and you can get a result. So that's it. Thank you for watching.